Hello! In this video we will explain the deviation measures in a cool real-life example. So now imagine you're an Olympic trainer and you have two teams of runners. In this competition, the less steps your runners do in 100 meters, the more competitive they are. These are your teams. Team 1 and Team 2. And these are the amount of steps each runner makes in 100 meters. As a trainer of both, you want to know which team is evenly more prepared. This means that each runner of the group has a similar level between them, so you can give them the right training. Now, as you can see, in the first team, the most prepared runner makes 34 steps, but the least one makes 120 steps. This means there is a huge difference levels of preparation between them. On the other hand, Team 2 has the most prepared runner makes 60 steps and the least 70 steps, making the running level more similar with only 10 steps between them. The only way you can know if your teams have low or big dispersion, this means if your runners are in a similar level of preparation or they have a huge difference, is by calculating the variance. To calculate the variance, we need to first find the mean for each group. As you may know, the mean is just the sum of the numbers, or in this case, the steps, divided by the number of runners. As you can see, both have the same average. We did this on purpose so you can notice that as teams, both are evenly prepared. At the end, each team makes the same steps, but inside each team, not all runners are the same prepared, so finding the average doesn't always tell you enough information. Step 2 would be to subtract each number from the average and square it. Step 3, add the results all together. And finally, Step 4 would be to divide the result by the sample size or the total amount of runners. As you can see, and you probably expected, the result for Team 1 is way higher than Team 2. This means that the first team has a bigger dispersion, or the members of the team has a big difference of preparation level between them. With this information, you know that in Team 1, your runners need different level of training. However, members of Team 2 can deal with more or less the same training level. You may use this information to solve many other questions, like how would you be the perfect combination of runners for the most prepared team as a whole and win? Although, to accurately compare both distributions, or both teams, we shall calculate the variation coefficient of both. The variation coefficient is just the standard deviation divided by the mean. The standard variation is the square root of the variance, giving us a more approachable value if in any other example the variance wasn't. When we calculate the variation coefficient for both, we can see that the one closer to 0 has less dispersion. Just remember, if these coefficients are too similar, we shall take into account the biggest mean between both distributions. Also, take into account that these are small groups of runners, and you don't have two or more runners making the same steps. If this was the case, the variance function would have a small difference. We will then have to multiply by the absolute frequency of each runner. Thank you very much. Hope you understood our example. Bye!
Created using Powtoon.